Today we have come together to talk about what you would think is a pretty back to basics kind of a concept, right? Thinking about class. And so to do that, we have with us Dheeraj. Dheeraj is working with Capgemini and has been a founding member of the CPP India community also. He's the technical manager there and oversees IoT based uh, some projects at Capgemini, uh, focusing on C++ based implementation. So let's see what he wants to tell to us about how to make our classes, how to be good. Over to you.
Thank you, Ankur, for this introduction and giving me this opportunity, actually, and most importantly, motivating me for the talk. Thank you, Ankur and Mahendra. Okay, so today we'll be talking about thinking in classes. So it's more about my view, how I think, what things I take care of or think when I have to design any class. And I think those are pretty basic one. I'm not going to give you any high funda. It's a very basic I'm going to cover in this talk. If you are a new in your C++ career, this might be new. And if you are a old veteran, yes, you are using C++ for a long time, like Ankur and Chris or others. So this might be a refresher for you. Uh, so let's begin. So we'll begin with the today's agenda. So I have a slide here for about myself and few disclaimers before I'll jump to the main content. Then we'll see a definition, what exactly a class is, and there will be a design goal, why actually we designed, what is the purpose, goal behind that. We'll go through some principles, basic principles. Those are for a more long time. Just we'll go through and we'll see a few examples. Then I have a hypothetical use case, a very simple use case where we'll design a few classes. Then we'll go through some core guidelines, which you can find also find on ISO. Those are directly from there. Okay. So while presenting, I'll not be able to see Teams chat and Q&A. So please try not to disturb me. Okay. I'll prefer to take questions at the end. But if you can't resist your urge, you can post your questions and queries in Q&A section or in chat window. We'll take that. And in my slides, you will see bottom right corner, I have slide numbers. So you can note down those for reference. Okay. So although Ankur has given a good introduction about me, but I'll just go through this slide. So I'm practicing software engineering for more than a decade. And why I'm saying practicing software engineering, because in these 10 years or 11 years, what I feel is I am still learning. So it's not I'm a complete software engineer yet. There are lots of hell stuff I have to learn. I have to practice, and then maybe in future, someday I will become master. So I'm practicing that. So primarily I'm using C++ and work in different domain and currently working in IoT. uh, Started CPP India 2 years back when all this Corona lockdown was there, and so I had nothing to do. So I thought this will be a good way to learn and share and build a community, and I think we are doing pretty good. So recently I started blogging and some podcasting. So you can visit jhadheeraj.com and you can find all those there. You can follow me on LinkedIn and Twitter. So that's all about me. I will not spend more time on this. And now we There are few disclaimers before I start the main content. First one is there is no perfect design. Your design will evolve over the time. On day one, you cannot say that this is a perfect one. That may be a good one for that requirement, but it's not perfect. It's a journey, not a destination. So it's a continuous work. You will have to continuously look into your design and evolve that over the time. Design may change with your requirements because requirements will change anytime and always. So the change in requirement is constant. So your responsibility is to minimize the change in your code. So that is the design you will have to do. And you will learn this by try and error. Okay. And very proudly, I can say by end of this talk, you will not become master in class designing. Okay. But you will get some clues when you can use those while designing your class. Okay, so yeah, these are the disclaimers. So now let's move to what are classes. So there is a very short and good video of Byan, and you can watch this video. And in this, he is giving a very crisp definition of classes. And here it is. The class as a thing you have in program to represent a concept in your application world. Okay. So if you are a mathematician, a matrix will become a class. If you are a businessman, a personal record might become a class. In telecommunication, a dial buffer might be a class. You can represent just about anything as a class. So I think this definition is very clear. I don't feel any need to explain this. Uh, the class is something which can which is a noun. Means noun is what is noun. Noun is a person, place, or thing. So you can anything which is noun, you can represent that as a class. So I'll come to how you will name a class. There are few points which I wanted to mention. One which I mentioned that it's a noun. So anything which is a person or any object, which you say object in the sense, let's say you want to say a laptop. So you can represent, I mean, your laptop will have some properties, it will have some functions. So you can club these properties and methods, and you can make it as a class. So it's a noun. Okay, it's a thing. I usually prefer not to use decorators. For example, that class database is better than class database factory, because when I'm using class database factory, I'm exposing that, okay, there is some factory mechanism in this class and I'm doing something. But when I'm saying it's a database, so user only knows, okay, this is a class to handle with database. Uh, User will not know what is behind the scene, whether it's a factory or what. Okay. So I usually prefer this. Limit the use of abbreviations. Those are good when you are typing. You can only type 3 characters and it will fulfill your purpose, but it's very difficult for reading. Someone who is coming from out of your domain and they might feel difficult. So your code should be readable. So that's why I try to avoid that. But uh, good rule of thumb can be that if you are in domain and the abbreviation is very common in that domain, so then maybe you can use, like, for example, if you are in finance domain and you are in taxation, so you can use VAT, value added tax. So that is a very well known abbreviation. That's fine, but otherwise try to avoid that abbreviation. And this naming is really not an easy thing. Uh, Maybe I'm talking that might look very simple, but it's not a very simple thing. So there is a talk by Kate in CppCon 2019. So you can go and watch this talk. I will not play it here. Okay. Okay. So now let's move to the design goals. I'll just give you one goal. So the goal of a software architecture or software design is to minimize human resources required to build and maintain the required system. So whatever you are building, if you have to change daily or maybe weekly, so that's not the good. So you should design in such a way that those iterations should be less. Okay. To achieve this goal, there are some principles. Those are, as I showed in agenda slide, solid principles, and those are those are in on web, available on web, and uh, very for a long time those are here. These are solids. S stands for single responsibility principle, O for open close principle, L for Liskov substitution principle, I for interface segregation principle, D for dependency inversion principle. And there are two beautiful talk on CppIndia YouTube channel by Hani Sukeshan and Hari Shankar. I will suggest you to go there and watch. Those are dedicated to these principles only. So you will get to learn something more. But here today also I'll give you a walkthrough of all these principles. So let's start with single responsibility principle. A module should be responsible to one and only one actor. Means your class or your module, it should do only one stuff at a time. Okay. So let's see one problem statement. I have a world famous employee class which has few data members and some associated methods. Looks good to use in an application, right? You have employee ID, string name, name, address, all those things here, and then you have few methods: calculate, pay, reported hours, and all those things. And if this is an inside an application, this will be used in different modules. Okay, each module might calculate working hour using different uh, formulas that reported hours. Sorry. So if some project want to use some calculation or some maybe for project tracking purpose, one module it wanted to calculate some hours which are spent by any developer or employee extra. So they might have some different calculation. Then there is a finance department which want to calculate pay, and they will calculate in different way. They will have set number of hours, like for example 9 hours in a day. They will calculate based on that. So that will be different. Okay, if you observe, it will be very difficult to manage these and in this class. And if you will change for one module, it will change for all. Then maybe you can go and you can have some if else and all those things. So can we do it in some better way? There might be multiple ways, but I'll give you one idea. So we'll have I'll create one class which will say R reporter, and I'll have a report hours function method in that. Then I'll have employee saver. So uh, it will save your employee data. And you might save that in database, or you might save that in a file system, or there are different types of database. So you don't know. So you'll have one employee saver class. And in your employee class, we'll have two pointers for these two classes. Okay. And while creating, I will create two objects of R reporter and employee saver, and I will pass those to employee and initialize my pointers with those objects. And definitely in my destructor, I will release those memory. And I'll add report hours and save employee hour. And I will call respective methods from them. Now, this employee class can be used anywhere, and each modules, maybe they will have to just implement their own R reporter class or employee saver class. Okay, they will implement their own and they will pass it to employee class. So your employee class will not change. It will have one responsibility that it will store all those information. Our calculation, you are delegating that work to some other class. Employee saver saving into database and all those things, you are delegating that to some other class. Okay, you are just invoking that. This pattern is actually Facet pattern. And I hope I'm clear here, right? So with this, I'll move to our next principle, that is open close principle. What it says is a class should be open for extension but closed for modification. So the general idea of this principle is it tells you to write your code so that you will be able to add new functionality without changing the existing code. Okay. That prevents situation in which a change in one class also requires to adopt all the changes in depending classes. Okay. So if class is closed, since it may be compiled, stored something. So, but it is closed. You are not going to change that, but it's open for extension. You can derive new classes. So let's see one example here. I have this product class, which will store my product information, name, color, size, and just these color and size are enum. I have not added here because of some space. And we have this filter class. What exactly this filter class will do is it has two methods, filter by color and filter by size. This will give you a list of vectors. Uh, Means you will provide a list of product and then it will check filter, give you a list of product which have some particular color code. Okay, so this is a filtering, simple filtering thing. This is fine until now you have to add one more property in your product class. Okay, maybe some geolocation. Uh, you want to track whether in which area of the world, in which country of the world this product is more popular. You want to filter in that way, or so this product is for which country. Based on that, you have some product segregations. So you want to filter that. If you want to do that, you will have to change your filter class, right? You will update that class. You will add one more filter method. So just to add one property, you will have to change your both of your classes. So what is the better way? In my view, is I will add one specification abstract class, and it will have some is satisfied method, and I will derive my filtering specific my classes for filters with this like color specification. If I want to filter for based on color or based on size, so I will derive from this. And then in my filter, there will be another abstract class for filter. So I will derive my better filter with that. And in that better filter, I will pass a vector of products. Okay. And I will also pass a specification pointer for specification, means base class pointer of my filter specification criteria. Base class pointer I will pass. So in this way, if I have to add a new filtering criteria specification, I will add one more class which is derived from specification, and I can pass it to better filter. And I will not have to update my better filter class. Okay. It will be means whatever I have written earlier, I can use that. Whatever specification are coming, I can add on one class only and it will work. So in this way, if you see, my classes are open for extension, means I am deriving from a specification, but closed for modification. I am not modifying my filter class. Okay. And in this filter side, you can have some more filtering kind of stuff. If you want to add some more filtering mechanism, you can also do that. Again, you will not have to update or change your existing classes. You can add new one that are better. From this, we'll move to next one is Liskov substitution principle. What it says is subtype must be substitutable for their base types without altering the correctness of the program. Okay. Functions that use pointer reference to base classes must be able to substitutable by derived classes. What it means is we'll see one example next, and then we'll observe how it works. So you have a bird class. Okay, bird object class. In this, you have three methods. One is set location, set attitude, and draw. So assume you are developing one app where you have different birds, and you want to track their movement, and you want to draw some graph or something. So draw function is for that, and you want to check location, that lat long, and then you want to check their height also, how high they are. So based on that, you will draw one graph. This looks good. You can add any number of, means all your birds you can derive from this bird class. But there comes one penguin, which is a bird, but this cannot fly. But because you are deriving from bird, you have to use set altitude. And but you have to add this class, but you will not provide any definition because altitude does not make sense with penguin, which is not good, right? So it does not satisfy your principle because you have something which is not used. So if an override method, if it does nothing, just throws an exception or does nothing, you are most probably violating your Liskov substitution principle. So what you can do here is there is one solution. So in this you can do is you can add one method something, and you can add one if else, and you check the type of your bird object what you are passing, and based on that you will add one if else condition, and you will say okay, if it is a penguin, then you check arrange it on a ground, and if it is some other bird then you which can fly, then you call this arrange bird in the sky, like that. This will work, but it's not a good one. So one solution can be you add a method is flightless, and if it is true, means if this function is returning true, then you can say okay, this is a penguin and I have to arrange that on ground, and if it is false, then you can say I have to arrange that in a sky. Here you will not do type checking, but still it's not a good one because you'll still have one method like this, and based on that, so if any other bird is comes like emu, so it's not manageable. Again, you will have to do all these things. So better one will be I'll add one class bird, and only I'll add draw and set location in that. And another flightful bird I will create from this bird class, and I will add my extra set altitude method in that. Now, if I have to create an object for my flying birds, I will create an object from flightful bird. Okay, it will have all these draw, set location, and set altitude. And if I have to create an object for my penguin or emu, which cannot fly, I will create those objects using bird class. So in that way, I'll not have to manage these set altitude thing. Okay. Hope I am clear. Someone can respond me.
Yeah, there is
Very
okay.
good.
Okay. With this, we'll move to next one, which is interface segregation principle. And it says is clients should not be forced to depend on interfaces that they do not use. We'll see one problem. I have an interface for my television, and I'm adding few pure virtual functions to change channel, increase volume, decrease volume, play Amazon, and play Netflix. Okay. From this, I'll derive my smart TV, and it's fine. A smart TV will have play Amazon and Netflix thing, but my non-smart TV will not have these Amazon and Netflix. It cannot play that. But because I'm using the same interface, I will have to have these empty functions. So what I can do here is I can create one interface which is for only which will have basic features of a TV. Then another interface which will have smart features of your television. And I'll drive my non-smart TV with ITV feature, and my smart TV, in that I will derive both ITV and iSmart TV feature. So now my interfaces are segregated. Okay, so I'll not have to depend on one interface. So if you see something where you have methods which you are not using in your class, for example, in previous slide, we saw that in TV, non-smart TV, we were not using a couple of methods. Better to segregate at interface level. That will be more useful. Okay. Then it comes to our next and I think last solid principle. It's dependency inversion. It's saying high level modules should not depend on low level modules. Both should depend on abstractions. And abstraction should not depend on details. Details should depend on abstraction. Let's see one example. You have a file uploader class. In that you means in that you have to upload few files in cloud, and here you are using right now AWS. You are uploading in AWS, so you added one connect function and one upload file method, and using your AWS class object you are uploading your files. This is fine, nothing goes wrong. Now your requirement changes, and it comes like, okay, with AWS now we have to support Azure also, and uh, based on the configuration or something, if it is AWS, then if user is saying that I want to upload in AWS, it should upload in AWS, and if he is saying nah, I want to upload in Azure, it should go in Azure. If your requirement is like that, this solution will not work, right? So what we can do here is we can add one interface iCloud handler. Okay. And our AWS handler of class we can derive from this iCloud handler. And in our file uploader, we'll add a pointer for this iCloud handler. And when we are creating this file uploader, we can pass your concrete object, which is AWS handler. You can create an object and you can pass here. In my code, I have not added that, but you just get the idea. And using your cloud object, you are calling connect and upload file. And in this, your consumer classes, consumer application, it will use your file uploader, and they don't have to worry how it's handling inside. Means they will just means if you have to support Azure, you will create one class, Azure class, and you will pass it to file uploader. And your file uploader, user of your file uploader class can use it without knowing how it is handling behind the scene. So whatever you are adding, your file uploader is depending on your iCloud handler only. So your class is depending on your interface. Okay. And your iCloud handler is not dependent on AWS handler. Your AWS handler is depending on your iCloud handler. So both the requirements are fulfilling here. So we discussed a little bit about these solid principles. So now I'll come to a hypothetical use case. And in this, in this slide, I'll state that use case. Let's say you have to process few message types. Okay, few messages you are getting, you have to process them, and then you will store those into a queue. And after that, you have to send those to some other third party, maybe in cloud, maybe in database, or somewhere you have to send that. Okay. So this can be one solution for that. So you will create one class, send and receive message. We'll create one private queue, and we'll add some methods: store message, send message, receive message. And by adding private queue, we'll get abstraction also, right? Because user will not know which queue this is. User will not have access, right? But if you have more message types, what you will do in that case? How will you handle multiple types of messages? Simple. You can add one more send message receive class, and you will handle there. What if there are more than 10? You will create 10, but that's not a sustainable. You don't know how many types of messages will come, right? And another problem is, because you have queue inside your send receive message, for each type of message, you will create one more queue. So if there are 10, you will have 10 queues. That might give you a problem. It might be a requirement for you, but in general, you think you are repeating these queues. And because in our constraint, whatever we defined, we have to just send a message from left to right. So after a few days, you get another requirement where you have to add some common header in your message. And it's common header like client ID, device ID, or some metadata. You want to add that. Okay. So if we go with our previous one, what we'll have to do is we had 10 message types. We created 10 classes. Now for each class, we'll have to add these same metadata before pushing into the queue. So what you will do is you will repeat yourself. Your code will be duplicated, but don't repeat yourself. Try. Remember, you need to be tried. Okay. So this can be from receiving side also, sending side also. So what you can do is, I don't claim this is a perfect solution, but having this constraint which we set, the requirement, this is better than what we just discussed. So I'll create one message queue, and in that queue, I will create one private queue, and I will add one push message. I will add my metadata in the message here in this push function, and then I will push that into my message queue. Okay. Here you can ask me that this push method you said couple of slides before that single responsibility principle, you discussed about that, and some things, whatever entity you are having, it should do one thing, but here your push method, because its name is saying push, and you are doing two stuff here. You are adding metadata and then you are pushing also. So you are violating single responsibility principle. Yes, I am. But at the same time, what I am getting is I am abstracting this metadata from outside of this message queue class. So the user of this message queue class, or whoever is sending or receiving, they don't have to know what this metadata is, what all metadata we are adding in this message. And by doing this here, by adding this metadata here in push function, you will make that at a central location. So if there is some change in future in metadata, you can do here at one place only, and it will reflect everywhere. So this is what something I'm achieving by breaking this single responsibility principle in this code. But again, these are some guidelines which we should follow. But again, there are trades off. Sometimes you'll have to break some rule to achieve something more. Okay, so it's not a fixed rule. Moving forward, my send message will, I'll take this send message, create this send message class, and the queue object which created in the class queue class, I will take its object in my constructor, and I will store that as a reference, or you can store it as a pointer. It's a matter of choice. I'll prefer to store that as a queue here, so that I will always refer, this send message will always refer to the single queue only. So that you can do. You can take pointer if you want to deal with multiple queues. But the idea is I will pass that queue object into this send message, and I will use this send message to uh, get a message from somewhere and push it into my queue. And in the same way, I will have a receive message. Sorry, in send message you will get from queue and pass it to someone else, and receive message you will receive from somewhere and you will push into the queue. And in the receive message also, I will pass my queue, same queue in this scenario, and both of these objects will work with the same queue. Now I have three different classes. Now let's say I have to add multiple types of messages. So I can create one, what you say, abstract class and interface class for types, and I can derive my different types of messages out of that, and I can pass those objects in these uh, to these classes, and I can push into the queue. My queue is a type of it's a type interface class. It's of that, and I can push any type of message in that queue, right? So this solution is better than the first one we saw with a single class. And over the period, means when in my initial days, I used to think why my code has so many classes when I can do in one class only. After these many years, I got to know, I got this understanding. No, those are required for extension. Means we'll have to, if you see, our initial design had only one class, but this has 3 classes, and there might be more, but those are easy for extension. Those can handle multiple type of data. Okay. So with this, I believe this use case is clear, and we'll move to some core guidelines. Now there will be less code and more talking. So this is the link. You can follow, you can read all the guidelines. There are more than, I think, 150 core guidelines. I'm not covering all. There are few I am covering here because if I want to cover all, it might go a very long time. So first category, so I tried to categorize them, these core guidelines. So first is organizing your data. So you can, so first core guideline is organize related data into a structure, either a struct or class. So you, what it says is, if your data is related, don't just create X and Y. Let's say you want to draw something and you want to draw one line from one coordinate to other coordinate. So try to make them as a structure or class as a point, and then use that. It's more readable and more maintainable, right? So organize, relate means you club those related things. Use class if class has an invariant. Use struct if the data members can vary independently. So what invariant is, if your data is related. So let's say you have a date. So in your date, you will have day, month, year, day, and the exact date. So these are related, and these will not go means like randomly. These will not change. There will be some constraint. So okay, if month is changing, so date cannot go more than 31 or something. Those conditions are there. So keep all these into a class, because you will have something to handle. You will add methods also. But if you want to just store some data, some random data, then you can go with the struct. Then the next category is encapsulation. Okay, so represent the distinction between the interface and implementation. If I have a class cloud connection, so what I'll do is I will add one public interface, say connect, and I will hide my internal details, because when I'm going to connect, I'll have to check for internet availability. I will have to check the connection string, okay, where I have to connect. But as a user of this cloud connection, that user need not to worry about all those things. It will just say, hey, just connect me. So by making them public, means connection method as a public, and connect, check internet and get connection as a private, I'm making sure these two interfaces and implementations are distinct. Okay. In the next, it says comes is minimize exposure of members. So you try to expose less, means try not to expose members, means your members should be hidden. So if in foo, if you see, we have a bar, we have a do bar, okay, and we have some private data. So private data, we uh, hide them in our private. Then in public, we are exposing something, okay, and we are doing some public bar, we are exposing this bar function, and we are calling our protected data. So this do bar cannot be accessed from outside world, but because it's protected, do bar is protected, we can derive, we can use it from our derived classes. So that exposure we should control, although you should avoid protected also, and I'm not going to touch that topic right now. So I hope this is clear that how you can uh, hide your data. So this is also known as data hiding. Yeah. For inheritance category, first core guideline says is prefer concrete type over inheritance. Concrete types is fundamentally simpler than hierarchy. Okay. So if you don't have any strong reason to have a inheritance, prefer concrete one. If a class is a part of hierarchy, okay, we'll be manipulating that using pointers and references. Okay, and when you are using pointers, okay, then you will take use there will be some memory overheads, some allocation and deallocation stuff, and more runtime overhead, right? So try to avoid those. Use abstract class as interface when complete separation of interface and implementation is needed, and we saw that in our interface segregation, right? Don't make a function virtual without a reason. There are some overheads of having virtual functions because there will be one virtual table and you will add one extra member in your class if you are making a virtual function. And there is a very good talk by Ivica on this topic. And in that, he's talking about uh, in this, he talked about the performance price of virtual function. I'll suggest to look into that before you start using virtual function. Now, the next category is default constructors. If you can avoid defining default constructor, please do that. Please do not add constructors just for the sake of creating that. Because if you do that, if you create a one constructor, any kind of one constructor, it will tell compiler, or compiler will assume that you are smart enough to handle your code, and it will not add other default constructors. Okay, so if possible, do not add any default constructor or destructor, any default operations. That is also known as rule of zero. But if you are defining or deleting explicitly, then do this for all. Okay, either you define all 5 constructors and destructor, or you don't do that. Okay, so this is also known as rule of 5, because if you add one, compiler will not add other. So what if you want to say compiler explicitly, no, hey, I defined one, I needed one, but for others you use default one, then you will have to tell your compiler that, okay, your constructor and it's empty, and that you will say default, so it will use default one. So moving to the construction of your object. So this core guideline says construct a fully initialized object. If for some reason, and the continuation is if a constructor cannot construct a valid object through an exception. So if for some reason your construction of your object is getting failed, for example, if you are opening a file in your constructor and that file opening is failed, do not let that object get created. You throw an exception immediately, because leaving behind an invalid object is asking for trouble. Okay, you don't know what will happen, so better to throw an exception immediately. Okay, and don't use default constructor only just for the sake of initializing data members. Let's say you have integer and you have a string, and you wanted to initialize them with their default values. So for that purpose, initializing integer with 0 and initializing string with uh, empty string, for that purpose, don't use default constructor, or your compiler will take care of all those things. All your default is compiler generated constructor will take care of those things. So for those purpose, don't do that. But if you are having something specific for your class, let's say you have some just I said you have to open one uh, file in your class, then definitely you add your constructor there. With this, I'll move to the destruction part. And this core guideline says is defined as destructor if a class needs an explicit action on object destruction. So you created one object, you created one file pointer, and you open in your constructor or somewhere in your class. So it's your responsibility to close that. Okay. So in your destructor, you should release that memory. Okay, so all the resources acquired by a class must be released by the class destructor. Okay, if a class has an owning pointer, just we said discuss, define your destructor, and this is also known as resource acquisition is initialization, RAII. And with this, I am done with my presentation. Here are few references which I will add few more in this list, but well, you can go ahead all this, and there are lots of stuff in ISO page which I shared earlier. There are lots of core guidelines, and I will to suggest you to go through all those, and yeah, that's all. Those are very helpful. That's all from my side.